Welcome to Introduction to Maya series. I am your instructor Rohan Page. In this video, we will see attributes of particles. What will be our workflow? First, we will see the attributes of particles. Then we will discuss about how to control the lifespan of particles. After that, we will see what are the types of particles available in Maya. Then we will see how we can add coloring the particle attribute for the existing particles. Let's start with the session. Now we need to see what are the attributes of particles. In the previous sessions, I have explained you about how we can create particle with particle tool, how we can create particle with emitter, what are the types of emitter, but we haven't discussed about the attributes of particles. So let us see what are the attributes of particles. First of all, I'll just create an emitter. Go to, first of all, make sure that you are working with dynamics module. Go to particles and choose option called as emitter. To change the background color, press Alt B. Now it is emitting particles in all direction. By default, I am using omni emitter. I'll just increase the number of rate to 300 and I'll increase the speed to 2, twice the speed I want. Okay. Now we have seen what are the attributes, basic attributes of emitter. To see the attributes of particle, you need to select these emitted particles and go to attribute editor. There is an option called as particle shape where you will find its attribute. The first attribute which I want to explain is about conserve. Conserve is nothing but the energy of that particle. So as you can see, as the particles are getting generated throughout the time, the energy is same. If this particle has been emitted from frame 1, so till the end frame, the energy of particle is same. It is getting generated with the same energy in a 3D space. So what if I'll reduce the value of conserve? Conserve value works from 0 to 1. 1 is going to keep the energy live forever throughout the timeline. And if I'll use the conserve value 0, particles will be losing energy before, or they will not have energy to get generated. You can see those are just getting generated at the origin. They are not coming out of that emitter. So there is no energy. So if I'll reduce the energy to 0.5, so they will not be able to travel as much in a 3D space. You can see how it is working. They are losing their energy. 0.9. They are just getting generated over here. And this conserve also depends on the speed you are using for the emission. So suppose I am using a speed, for speed select the emitter and I'll increase the speed to 8. So see how they'll stop, right? So at some point particles are losing their energy and they are stopping because conserve is reducing their energy after they travel few distance in a 3D space. So this is how conserve works. I'll select the particles, again go to attribute to see the attributes. I'll change the conserve value to 1. That means they will not lose their energy throughout a 3D space. Now there is an option of lifespan. There is a rollout lifespan attribute. You can see that the particles which are getting generated, they are living forever. They are not dying at all. Even if I am reducing the conserve, they are getting, they are gathering at a point, but they are not dying or not disappearing. Because lifespan mode of a particle is live forever, which means once a particle is generated from an emitter, it is not going to die, it is not going to disappear or anything, it will live throughout the timeline. You will be able to see from first frame of its generation till the end frame. If I'll change the lifespan attribute to constant, this options get active, lifespan 1, which means particle will be able to be present in a 3D space till 1 second from the time of generation. So all the particles are getting disappeared, you can see, after 1 second of generation. If I want to make them disappear from half of a second, play it. You can use 3 seconds so that they'll get generated little bit till more time, and then they are disappearing like this. But all the particles, if you'll observe, I'll just make it a value 0.5, all the particles are sharply getting disappeared at one point. You can increase the number of particles to see the effect very well. I'll just select the emitter, change the rate to 1500 and check how they are dying off at a certain point. You can observe there is a sharp circular spot over here. That means all the particles are kind of getting disappeared at same distance. Everyone have same lifespan, same unique lifespan, you can say. There is no randomness. So to add that kind of randomness, we have another type of lifespan mode called as a random range, where you can ask few particles to disappear after 2 seconds of generation, and few will get disappeared after 8 seconds of generation. Let us see how it works. I'll just have less number of lifespan randomness, so 1. So now few are getting died off at 1, few are getting disappeared around 2 or in between. So there is no sharp kind of a circular shape. So randomness is there. Few are dying off within the 1 and 2 value itself. So you can add randomness in particle disappearance or lifespan. Lifespan per particle only will give you the authority to use scripting, and you can assign per particle lifespan. You can few particles can die around 1 second, 2 second, 4 second. The more kind of a control you will get, but for that you will need to use mail script. So we can use constant random range if we don't know about how to work with mail script. So I'll go back to live forever so that my particles are now again can be seen throughout the timeline. The next thing which we have is a particle render attribute, where we can see there is an option called as particle render type. So there are two main particle render types. You can see that when I am generating particles, by default I am able to see it in a point shape. All the particles are represented in a point shape because particle render type is point. So we have two categories, two main categories. One category is hardware rendered particles and other category is software rendered particles. The particle type in front of which it is written in bracket SW, which means there are three types of particle which can be rendered by using software, but whereas other point types cannot be rendered with the help of software render but by using hardware. So now we were in a point category, which means we are using hardware rendered particle, and if I'll render it, you can see there is nothing in the render window because the render engine is Maya software. So I'll change this render engine to Maya hardware and now play and take a render. You can see the particles. So let us see what are the hardware render particle types available over here. So click on multi-point. There will be a bunch of particles like this. No more number of particles are getting generated. If you want to control the value or any more attribute of this particle render type, then there is an option called as add attribute for. Whatever the render type will be, it will show you the attributes for that render type. So click on this option called as current render type, and there are few options like how many particle count you want with each set of particle. It is saying 10 particles. That means there is a bunch of 10 particles which are getting generated from the emitter. I'll increase it to 50. You can see the number of particles in each set has been increased to 50. The maximum radius they got spread is 0.3. So if I'll increase it to 0.8, you can see they are now spreading from each other, getting away from each other. There is an option called as point size. Point size is 2. If I'll reduce it to 1, you can see how they are looking now. Looking like a dust. If I'll increase it to 5, that will be more prominent in a shape. So this is the multi-point particle render type. The next particle render type is multi-streak, but before that we will see streaks. Streak is nothing but lines. You can see how this looks. Click on the current render type to get the attributes for it, and there is an option of line width. You can increase the width of line like this. You can increase the tail size, how length, you can say length of that thing, and this is how it works. You can add tail fade. If I am adding it to positive, it is becoming prominent line throughout. Reduce the size to 1. Now there is other render type as multi-streak. So bunch of multi-streaks will be getting emitted like this. Again, you can have the options like how many count of streak you want per streak. This is 50. You can reduce it to 10, 20. You can also spread them within 0 to 1. It's up to you. Next one is numeric. You will be able to see the numbers for the particles which they are at what number of particle is that 1093, 1054. After the emission they will get a certain amount of numeric number. This is the particle number 448. Then there are the particles which are 623, and like that there are numbers which you can see over here. The other type is sphere. Click on that. You can see the sphere radius is too much. You can reduce it. You just need to click on the render type so that it will give you the attribute called as radius. I'll reduce the radius of sphere to 0, 1. So this is how it looks. But these are not renderable in Maya software but in Maya hardware. Next one is sprites. Sprite, I'll just click on the current render type. I'll reduce the amount of particle I am emitting, like 1500. I'll make it to 50 so that I'll be able to see sprite in a proper way. You can see these are nothing but a polygon, kind of a plane thing which is planar. But advantage is whenever you will rotate the camera, those planes are always facing towards your camera angle. You cannot see its side view or anything. They are always facing towards the camera angle. So you can use sprite for multiple purpose, like creating crowd simulation. You can use it to create smoke and all. So this is how it works. Wherever you will rotate the camera, those planes are going to face towards it. The next particle type we have, these are the particle type which were in hardware render type, and next one is software render type, that is Blobby Surface. Blobby surface is also like a sphere only, and you can render it with the help of Maya software. The next type is cloud. Particle cloud, click on that and increase the radius to 0.5. You can use it to create snow or something like that. Though the shade of that particle cloud is gray, but when you'll take a render, you will see the color of particle cloud in blue color. And why is that so? Go to Window, Rendering Editor, Hypershade. In Hypershade, you can see there are default set of material where particle cloud is one of the default material available. So this is the material which is applied by default on particle cloud type. So if you double click to see the attribute, it has this blue color. So click over here and change it to white, and now take a render. You can see that there is a white color. So this is particle cloud render type. Select the particles to change the type, and the next one is tube, and take a render. This looks like this. So these are the types of particle which we have. Now if you want to color the particles which you are creating, I'll just increase the number of particles, 1000 particles I want. You can see that the particle color is gray. You want to change the particle color. So go to attribute editor. There we have an option rollout called as per particle attribute. Click on the color attribute. It will ask you whether you want this attribute per object attribute or per particle. Let us see how it works. If I'll turn on add per object, add. So there are set of options which will be available over here, called as color red, color green, color blue. All the values are in black, so that particles which are getting generated will be in a black color. If I'll add a value of 1 in color red, you can see that the particles now are getting emitted in black color. No, sorry, red color. I'll make it 0, and for green I'll make 1. So it is kind of a per object you can use color. You can, to mix it, you can just add 0.5 and it will change the color accordingly. So these are the most available combination, but the overall particle color will be the same, unique color. Now what if I don't want this kind of color? Add per attribute, per particle attribute. Now there is an option got added in this rollout called as RGB PP, that is red, green, blue color per particle. How to work with it? Because right now I'm getting the same color. So right click over here in RGB PP, and there is an option called as create ramp. Click over this option. To see the ramp, I'll just play it. You can see that the ramp color of a gradient from gray to white is available over here. Right click. To edit the ramp color, right click, array mapper, and choose edit ramp option. I'll change this ramp color from white to some kind of yellow. Red. Now you can see how it is looking. You can add multiple colors. So this is how you can color the particle with the help of ramp. Now these are the particle attributes which we will be using according to our examples, and this is how their attribute work. We have seen lifespan, how we can control with the lifespan, how we can have the different kinds of particle types, and how we can color it. Let us see what we have seen in this lecture. What we learned in this video. We have seen that conserve is the energy of particle, reducing the value towards the zero so that particle will lose their energy, or else if the energy or the value of conserve is 1, then the particles will not lose energy throughout the scene. We have seen that live forever, constant, random range, and lifespan per particle are the types of lifespan mode available for particles. We have also seen that multiple point, multi-streak, numeric, sphere, point, sprite, and streak. These are the hardware render type particles. Whereas blobby surface, particle cloud, and tube are software render type particles. For any query, you can follow me on Facebook, you can write me an email on rohan.pagianimator@gmail.com, you can subscribe to my YouTube channel, or else you can join the classroom with the following code. Thank you.